the first time, right? Programming. I think you've already given your thoughts on this. That took a bit of a while to get used to, but then after a while it became second nature. Did you learn a lot through this?
I did, yeah. From a junior perspective, Tim had a lot to teach me. But I think it's through the discussion when we're discussing. I mean, a lot of the times, Tim just talking to me, he would solve the problem himself. Right. So even though I didn't really contribute any help, Tim would, just by him talking to someone.
I think that's called a cardboard developer. You speak to the cardboard developer and figure it out yourself. No offense.
Most of the time I'm arguing with myself about implementation.
This is actually what my desk looks like at the moment. We're trying this out actually, having 2 keyboards, 2 monitors with the same thing on each monitor. And then the idea is that people, when you just have one, especially one keyboard and one mouse, there's sometimes a bit of, the person who's come to sit at your desk won't necessarily just grab the keyboard or the mouse, and sometimes they end up sitting doing nothing and getting a bit bored and disengaged. So this is just to encourage that. A nice experiment to do is just to take a second mouse and stick that on your keyboard, on your desk, and you'll be amazed at how, when people come to talk to you, next thing you know, they've got the mouse and moving it. And I think it's good to encourage. So good, I have 3. These guys did an exercise at the University of New Zealand, of Auckland, and they put half the people in a pair programming team and the other people acting solo programmers. And the results show that a significantly greater number of the paired students passed the course compared to the solo students, and they also did a lot better in the scores and assignments in the final grades. So it would have really been bad luck to end up in the solo team. So code reviews. Actually, I'm just wondering what the time is here. Should we finish the whole talk and then do the exercise, or? Okay. All right. I think we're doing quite well for time. So, okay. Are there any questions about this one? Okay. So code reviews. I think the concept, the idea of this project was to keep code good instead of trying to. I think that was easier to keep the code good as opposed to take bad code and make it better. We did this talk at the company the other day, and I was worried that it came across as if the code is only good because we did code reviews. But these guys provided us very good code in the first place, and it's very nice actually to. Actually, Michael described this code as lovely. It's such a nice, so great to have code like this where you actually care about things like shouldn't that belong in another class, and the design is actually, hey, you actually feel a bit, if I had to take over this code, I would feel obliged to keep it good. I'm just going to, so we got some stats, and the point of the stats was to show where we should focus on during the code review. And with Visual Studio, actually, you can actually pull these stats up very fast. And just for this code review, a lot of these stats are actually related to method level. Just before I forget it, it would be good as well to combine this with, say, class level stats as well. So these are a little bit naive, but they're still quite important. There's a blog post called How Toxic Is Your Code? And they show a very nice way of visualizing code where you look at both method level and class level stuff. Okay, so here we have it's a Maintainability Index from Microsoft, and it's a bunch of stats that go together to tell you how maintainable your code is. And only if it's below 20, then it's poor, and if it's less than 10, then it's bad. And it's really bad then. So we did see that these guys were creeping up, and as we see the lines of code, as they increase, we see the Maintainability Index starting to drop, starting to come this way a bit. Another thing we looked at was Cyclomatic Complexity, which is basically the number of execution paths through each method. Okay. And we see again, as the methods increase in size, the cyclomatic complexity tends to get higher. But again, the industry average is, some people say you should keep it less than 10, some people say less than 15. And on this code base, it's not even, 4, which is very good. Yeah. So most code bases will be much higher than that, double on average, I think. this is now comparing, so we did our code review, the guys went away and spent some time improving the code, and we see the stats now of what it was like before, and the blue diamonds show after they've done the work, after getting some advice through the code review. And we see, this is the Maintainability Index. One thing we see quite evidently is that the lines of code for these, what would become troublemakers, that got chopped down. I think they're actually down here now. And a lot of the, I think a few more moved towards the right. And this one, the Cyclomatic Complexity, also, these guys here that were causing trouble, they came right down, got them back in line. Okay. And what does the code look like now, near the end, after the first delivery? And as you see, some of the guys are creeping up again, but still, the Maintainability Index is very nice, very good. And also the Cyclomatic Complexity is amazing. So if we keep doing this, I'm sure this code will stay in a very good state. And the question is, of course, why did you spend so much time, getting so much quality? And I think that's a good question. And maybe it's because code that is of poor quality, it's not easy to spot defects in them. And one of the things we spoke about during one of the code reviews was too many parameters in a constructor, or too many parameters in a method, because if we look at what the UI design people say, that humans can only keep about 7 things in their mind at once. So if you have a parameter of 14 objects long, you will start to miss things, and bugs will start to creep in. So if you have a method that's 400 lines long, there's probably going to be bugs in there that you don't know about. So keeping bugs out stops this thing from happening, where you have bugs appearing in operations, and as you can see, that according to these guys, that costs 150 times more than finding it in relative costs. So if we find it while we're coding or doing developer tests, that's obviously a lot better than that. There's also this diagram which shows that code bases which have less defects in them have shorter development cycles. So doing relatively the same thing, if your code has fewer defects, you will finish a lot sooner. So it's good for the long-term maintainability of code bases. And the other question, of course, is why should developers care about this in the first place? And I think that's why we have to get developers engaged and get them to want to do a good job. Because why do we have developers working at home, doing their projects at home, which are 10 times higher quality than what they're delivering at work? And I think it's because the ones at home they care about. And just asking them when they're going to be finished is not going to help. It's not going to help them want to do a good job. Complexity is a big problem. Accidental complexity and cyclomatic complexity. And this chap, Peter Hullins from Microsoft, he says that developers spend about 80% of their time understanding what's going on, and only about 20% redoing things and 2% doing new code. Do you think it's true?
Yeah, that's true.
It's kind of scary, because if you look at lean startups where they don't have this much stuff to understand in the first place, they can get a lot more of the new work done and catch up quite fast. And this I don't think this is a problem if you have short development cycles. So if it only takes, say it takes you 8 minutes to understand the thing, and then you can implement it for 2 minutes, then you'll be okay. Then the less, if you have to spend say 8 hours understanding and then 2 hours implementing, then you're much less likely to say, okay, now we need to still improve this. It's almost like a downward spiral, that if the longer you take to understand it, and then you just write a few lines of code and you start to think, oh, crumbs, it's embarrassing, I've spent so many hours and I've just written these 2 lines of code, I'm not going to spend any more time fixing it. But when it's the other way around, the shorter the cycle is, the more likely you are to hang around and make things a bit better. And one way to judge the cycle is to look at the number of check-ins people have done. And so these guys haven't really seen this graph yet. How many do you think you check in per week? How many on this project? What do you think your average is?
Around 30, 21, 30, I don't know.
All right. And you use it about 6 times a week, 5 times a week?
I didn't say that, yeah.
So the actual stats are, commits to a week about 32. All right.
See?
Yeah. this guy here is kind of useless.
Yeah.
This is me. Yeah, so I can't say it didn't help. And this is Lee, and okay, there were 3 guys in this project, so you don't appear.
I'm in the middle of this.
Yeah. And we see here that we see at some points, what I find interesting about this graph is that it doesn't go up and up and up near the end of the project. It's at the beginning where a lot of the work happens, and then, you know, this is a slow, comfortable, maintainable pace as it comes down to an end. And it's not, this graph doesn't really reflect that Lee did all the work. It's because they were pair programming and checking in from Lee's computer. I hope for your sake that's what happened. So it's, when you're checking in 70 times a week, I think you're not spending that much time trying to understand. You are actually doing some work and checking in again. And I still think that these things help a lot. TDD and BDD. You can end up in a lot of trouble if you get these wrong. Actually, it's not like it's not a perfect fix, but you need to be a bit careful and constantly watch quality when you're doing these exercises, these practices. So I don't know, you guys have you done TDD before or yeah, but I think it was BDD that was the first.
Yeah.
So TDD, as described by Kent Beck, he kind of shows the difference between doing it and not doing it. And if you don't do test-driven development, what you do is you write the code, fix the compile errors, and then step through with a debugger. And this happens a few times a day. Whereas if you're doing TDD, you spend a lot less time with the debugger. And you can get through the cycle a lot faster. And each cycle you're actually learning a little bit. BDD is a little bit different than TDD. Well, BDD actually came about because people were having trouble explaining TDD. So this is kind of like TDD done properly. So the difference is, here we have a higher level acceptance test, and we write that, and then we step down into unit testing, where we do lower level tests here. These are more like integration tests. And it's very much in line with the way people think. When they solve problems, they go from higher levels down to very low levels, and in the middle, and up and down, and up and down. There's a good diagram in the Agile, in the Lean book by Mary Poppendick, but I didn't put it up because she said used with permission, and I didn't have permission. The BDD stuff we did, the automated acceptance tests, were actually hitting the web service, but not really as a client, so that they can run easily without having to launch a web service. We did try to have tests here, so going forward, if we really wanted to do work and release it in the same sprint, we would have to, as this grows, we can't spend that much time doing regression tests. We need to automate that. So going forward, we will test this. We did try a few times, but we were let down by basically Microsoft's coded UI. There are some special controls that this Excel sheet is using that coded UI couldn't deal with. So we had to maintain a balance between the work we were doing and the effort going into testing.
What libraries did you use for the BDD?
SpecFlow, which is .NET's Cucumber. Very nice, actually. So it's a very low barrier to entry because it's still, if you're doing C#, it's still in C#, and it's almost no setup time. Very, very good, actually, and it's for free. If you're doing Java, you can use Qt for Duke, or plain old Cucumber if you like, the original. It's kind of weird because you get, the Java one is Qt for Duke, and then there's a .NET implementation of the Java one called Qt for Nuke. Anyways, but we use SpecFlow, which we found very, very good, actually. SpecFlow combined with coded UI. So our test coverage now is 80%, which I think is very fair. Yeah, very good, actually.